In this video, we're going to be going over descriptive statistics and graphs for numerical variables. So recall that there's kind of two main types of data. There's numerical and categorical. The way we describe each is different, and so we're going to just go over the numerical one. So when looking at numerical data, remember that's when the variables can take on numbers, and so we typically want to describe the distribution of those numbers. And so there's three main characteristics that we want to look at when we're describing the distribution, and those are shape, center, and spread. So let's start with shape. So when looking at shape, there's two main things about the shape that we want to look at: symmetric versus skewed, or how many modes it has. So basically whether it's unimodal, if there's kind of one peak, if it's bimodal, if there's two peaks, if it's multimodal, if there's more than two peaks. So basically these two are the main things, just the number of peaks it has and that symmetric versus skewed. So an easy way to look at this is by just looking at a histogram. So this is data from an email data set. So this is the number of characters that each email had. And so you can tell that this is first a right skewed distribution. That is, the tail is on the right side. You have a lot of emails with a low number of characters, and you have a few emails with a lot of characters. And you can also tell that this is a unimodal distribution. Basically, there's just that one peak that's really low, close to zero, and then it doesn't really go back up again. So basically, just this is a unimodal distribution that's skewed to the right. So that histogram does a good job of kind of summarizing the data by putting the numerical values into bins. Another way of visualizing the data is just by using a box plot. So basically this is an example of a box plot. This is plotting data about songs and the tempo of all of these songs. And so you can kind of tell that you have all of these points here where you can describe the distribution. So you have the median, you have that first quartile, which is the kind of leftmost edge of the box. You have the third quartile, which is the rightmost edge of the box, and so these are the 25% and the 75% percentiles, and then you kind of have the edges. So basically you have the rest of the 25% below the left side of the box, and then you have 25%, the high 25%, above the right side of the box, and then you have a few of those points representing outliers. So this is another way to kind of tell what the distribution of the values look like. So, basically we're able to kind of get an idea of the shape of a distribution just by looking at these graphs. But what if we had to use one number to describe a distribution? How might we do this? And this is what that measure of center is trying to get at, this measure of central tendency. The idea is that we want that one number summary that approximates what that variable is. And so we usually use two main methods of kind of summarizing that measure of center, and that's the mean and the median. So mean is just the arithmetic average, and this is something that a lot of you are probably familiar with. You just kind of add up all the numbers and then divide by the number of numbers. So if we have this group of 5 numbers, 1, 2, 4, 6, and 7, basically the mean is just add them all up, divide by 5, and that's your mean. And so basically what we're saying is that 5 kind of is a representative number among all of these numbers. For the median, we're just kind of taking that middle number, the 50th percentile. So we just put all those numbers into increasing order and then take the very middle one. If there's an even number of numbers, we would just kind of take the average of the middle two. Right? So if we have this same group of numbers, 1, 2, 4, 6, and 7, 4 would be the median because it is that middle number. So we have this one number summary that can describe this distribution, but that doesn't tell the whole story. Right? So consider the following two sets. Right? So we have 0, 0, 30, 60, 60, and then we have 28, 29, 30, 31, 32. They both have the same mean and median, right? It's both 30, but the values that they take are very different. And so, we want to be able to describe these distributions very differently. And so, the difference between these two is that the first set of numbers is more varied, right? It goes all the way down to 0, all the way up to 60. Whereas the second set only goes from 28 to 32, so it's much more closely grouped around 30. And so their spreads are different. So measure of spread that's commonly used is standard deviation and variance. Right? So the variance, we have this complicated formula here. You don't have to worry about this. The idea is it's this average square distance from the mean. So we take the mean, we find the distance of each of the numbers from that mean, we square it, and then we basically take the average of those numbers. And then the square root of that is the standard deviation.